Hello, hi everyone. Welcome to the last video of this one-shot series. In this video, I'm going to discuss some previous year questions of biomolecules. Easy chapter, important chapter, but yes, there are so many things which you need to learn in this chapter. Okay, so let's start from the basics. Let's start systematically. So first, I'm going to discuss the weightage, then syllabus with the help of mind map, and then we will solve some previous year questions. So who will benefit from this video? Who knows the basic? Who knows the basic? It means you have to learn some structures and important information, important information. This is very important. So you have to learn that part. So if you don't know anything about biomolecules, so at this time, what you can do, you can just revise NCRT. So you can solve some of the questions of the biomolecules. And if you have taken coaching somewhere, then revise your notes completely, right? Revise notes completely because there are so many things which you need to understand. Okay. Now, how to use this video? Revise short notes, jot down the important information, and then start doing the practice. If we talk about the weightage, so one question is going to come, so it means 4%. General weightage is 4%, so you can get one question from the biomolecule in your exam. Now, in the biomolecules, we have carbohydrates, we have proteins, nucleic acids. So there are so many questions which are from these three topics: carbohydrates, proteins, and nucleic acid, right? So there are some questions which are based on vitamins, but few questions, right? But most of the questions are from carbohydrates, nucleic, and proteins. In the carbohydrates, you should know everything related to glucose and fructose. Structure is very important. Chemical properties, they're very important. In disaccharides, sucrose, maltose, lactose, you should know the structure of these. Structure or uh, glycosidic linkage is present in between which carbon. Okay, if whether this is the polymer of alpha glucose or beta glucose, so this is very important. Polysaccharides may be same. You should know the structure of starch, cellulose, and glycogen, and what are the important components of the starch, right? Amylose and amylopectin, you should know all these. Now protein may, there are so much things to learn. For proteins may we have amino acids, so you should learn amino acids. You should learn amino acids, essential amino acids and non-essential amino acids particularly. Then you should learn the structure of amino acids. Structure of amino acids. Structure of amino acids. Okay. One letter code, that is important, right? One letter code and structure of amino acid is very important. Okay, now in nucleic acid, what is the structure of DNA? Which sugar is present in DNA? Which sugar is present in RNA? Okay, then what are the nucleic acids present? Okay, just thymine, uracil, adenine. So we have some nucleic acids, right? So you should know all these things. Clear? Then vitamins has, so this is completely based on memorization. Okay, so I have written few, or I have put some important information which you must know before starting with the questions. Like what is glyceraldehyde, the deglyceraldehyde, tetrose may we have erythrose and threose. Erythrose may both OH, they are on the same side. Threose may they are on opposite side. Then pentose may we have ribose, arabinose, xylose, and lixose. Okay, so what you are going to do, how to write down the structure? CHO above in all, then CH2OH below, then OH, first OH on the right hand side. Then we have total 4. So 2 OH on the right hand side and 2 OH on left hand side. Then 1 OH right hand side, 1 OH left hand side, 1 OH right hand side, 1 OH left hand side. In that way you are going to learn. Then hexose is very important. So you should learn all these. So there is some mnemonic. So that is all altruist. All altruist gladly make gum in galloon tanks. Okay, so again you have to do in that way. First what you need to do, CHO above, CH2OH below, CHO, CH2OH, CHO, CHO, CH2H, CHO, CH2H, CHO, CH2H, like this in all. Okay. Then in all, first OH is on right hand side. Then 4 OH on right hand side, 4 OH on left hand side, then 2 OH on right hand side, 2 OH on left hand side. In that way, you are going to learn the structure. Okay, so this is the important part, that you must know about the carbohydrates, then what are reducing sugars and non-reducing sugar. So reducing sugar, which can reduce tolerance regions and all. So all monosaccharides are going to be reducing, and all oligosaccharides except sucrose. Sucrose is the non-reducing sugar. Then we have non-reducing sugar. All polysaccharides are non-reducing, and we have one oligosaccharides which is non-reducing, that is the sucrose. Okay, now you should know कि which ग्लाइकोसिडिक लिंकेज इज प्रेजेंट इन maltose. जैसे अल्फा डी ग्लूकोज है, maltose is the polymer of alpha D glucose, and we have alpha 1 for glycosidic linkage. Sucrose is alpha 1 and beta 2 glycosidic linkage. Beta is fructose. So except for sucrose, we have all 1 for glycosidic linkage. Then lactose is the polymer of beta D glucose. So beta D glucose and beta D galactose. Right, so beta D glucose and beta D galactose. So again we have 1 for glycosidic linkage. ठीक है, 1,4 glycosidic linkage. So that is also important. So now here glucose is fourth. ठीक है, glucose is going to be the fourth one. Now we have starch, polymer of alpha D glucose, glycosin, polymer of alpha D glucose, cellulose, polymer of beta D glucose, and rest you should know these structures. So you can basically learn from your notes. Then we have non-essential amino acids. So we have this, in that way you can learn CATS, GGG, Then we have essential amino acids. So you can learn by PVT Tim Hall. Right. Then one letter code. There are so many questions on one letter code. So one letter code is very important. 3-letter symbol is very important. And the side chain. R group. Like in amino acids, we know that that amino acids are alpha amino acids, which forms polymer. So here we have COH, here what you can write NH2, here H, and this is going to be the side chain. So if side chain is H, so that is glycine. Alanine के लिए CH3, valine के लिए this CH, then CH3 whole 2. So in that way you have to learn all. Okay, all. So that is very important. One letter code is important. Then there are some functions of the enzymes. This is also an important part. So you have to learn this table. And then we have some vitamins. These are the critical things that you should know before doing the questions. Okay. Then beta D ribose, beta D deoxyribose. So this sugar is present in DNA, and left hand side sugar is present in RNA. So please learn it. Okay. I have provided everything, not everything, but most important things over here. Then you should know the structure of adenine, guanine, cytosine, thymine, uracil. करना ही पड़ेगा. If you don't know the structure, then you cannot do the question. So this is very important to learn these structures. Okay. Then structure of nucleoside and nucleotide. So in the nucleotide we have phosphate group, we have base, and this is the sugar moiety. Okay. And in nucleoside we do not have phosphate group, just we have base. Base means adenine, thymine, guanine, right? And the sugar moiety. This is the difference between nucleoside and nucleotide. Now I did not divide the questions into different types, so I'm going to do all the questions together, right? So this will give you the revision for the biomolecules. So let's do the question number 1, which is not true for arginine. So for that, you should know the structure of arginine. If you don't know the structure of arginine, you cannot do this structure. Okay. So arginine is the amino acid, and if I'm going to write down the structure of amino acid, so here I'm going to put COH, then NH2, here hydrogen. Now here we have R group, right? Some R group, and that R group is going to be which one? Which one is going to be this R group? That is CH2, 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 NH, then C double bond NH and NH2. Understood? So this is the R group. This is the R group for the arginine. So question says it has fairly high melting point. Yes, melting point is high. This is true. It is associated with more than 1 pK values. Definitely. like CO minus, then we have NH3 positive because amino acid exists in the form of zwitter ion. Then we have so many basic groups, this nitrogen, this nitrogen, and this nitrogen. So yes, we can have more than one pK value. This is also true. Now it has high solubility in benzene. No. Why? Because this is polar. So polar molecules are soluble in polar solvent, and benzene is non-polar solvent. Non-polar solvent. So this is false. Now it is a crystalline solid, true, because we can have hydrogen bonding, right? Melting point is high because we can have hydrogen bonding. We can have the concept of hydrogen bonding, due to which melting point is also high and it exists in crystalline solid. Okay, so what is going to be the answer, bache? It has high solubility in benzene. It is not true with respect to arginine. Now let's do the next question. So next question says the naturally occurring amino acid that contains only one basic functional group in its chemical structure. So first of all, you should know the uh, essential amino acids. Sorry, naturally occurring amino acids. Okay. अब now let's write down the structure of all. So in aspargine we have, see, this is common, NH2, CH and COH. This is common. So in aspargine we have CH2, C double bond O, NH2. Arginine we have already discussed, H2N, CH, COOH, and then we have CH2, 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 then NH, then C double bond NH, and this is going to be NH2. Now we have histidine. In histidine we have NH2, CH, COH, and then we have the ring CH2, and then we are going to form nitrogen, this nitrogen, this type of ring. Is it clear? So this is the histidine. Now we have lysine. Now lysine is, let me write lysine over here. So lysine is H2N, CH, COH, and here we have CH2, 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 NH2. Now point is one basic functional group should be there. So now we know that amino acids exist in zwitter ionic form. So if I'm going to write this structure, so aspargine, aspargine, we can write NH3 positive, CH, CO minus, okay, and then we have CH2, C double bond O, NH2. So can you see, we can have this basic group, right? We can have this basic group. This is the one basic group. We can also have this basic group in lysine, okay, but naturally occurring amino acid is aspargine. So it is a memory based question. You have to learn it. There is no other way. Understood? You have to learn which one are naturally occurring, which one are essential amino acids and all. Now, next question. The products formed in the above reaction are. Now this is important question and this is based on the reaction. So we have D-glyceraldehyde. So glyceraldehyde structure you should know. So what is glyceraldehyde? So we have CHO, then here CH2OH. D-glyceraldehyde, it means OH is going to be on right hand side. Okay, so this is glyceraldehyde, D-glyceraldehyde. So question says, if we have HCl, right? So what happens in the presence of HCl? Nucleophilic addition. We have to do nucleophilic addition. So if I'm going to write CHO as this, C double bond O and H. So Cn minus attacks on this carbonyl carbon. Electron of this bond shifts over here, which can further take H plus, right? Which can further take H plus. So by doing so, we get H, OH, CH2OH. Here we can write directly, I'm writing COH. Here we have Cn and this is H. Okay. After that we have H2O and H plus. After that we have H2O in the presence of H plus. So this is the hydrolysis reaction. So H2O in the presence of H plus, what do we have? Cn is converted to carboxylic acid. So what do we write? We can write COOH, CH2OH, and then we can write OHH and HOH. Clear? Because Cn is converted to carboxylic acid. Now in the next step, HNO3. Now HNO3 is the strong oxidizing agent. So it's a strong oxidizing agent. So it converts alcohol to carboxylic acid. So what do we have? COH, OH, H, H, OH and COOH. So this is the final product. Now let's see the statements. So statement says we have two optically active products. What are optically active products? Which can rotate PPL either through right hand side or left hand side. And one optically active and one meso product. So we have to basically find out the stereoisomers. We have to form different compounds with respect to this structure, right? Up now see what we can write. We can have the mirror image of this one. So if we have mirror image of this one, so COH, OH on the right hand side and here OH on the left hand side. Okay. So these are optically active, and we can have one meso product. Why? Because OH can be on right hand side also, no? This OH should be on right hand side because we have the decrystaldehyde. But above OH, yani this OH can either present on right hand side or left hand side. Is it clear? So it means we can have this. But in this compound, if you see, if this is a plane, if I am assuming this is a plane, so here we have plane of symmetry, because if you pass a plane like this, then it cuts the molecule into two equal halves. So this is going to be the meso compound and this is called achiral. Okay? And this is chiral, and chiral compounds, they are optically active. So what is going to be answer? Answer is we have one optically active and one meso product. Okay, we do not have two optically inactive products. No, optically inactive means we have one, that is meso product. Clear? Now let's do next question. So given below are two statements. One is labeled as assertion A and other is labeled as reason R. Assertion A says solution of the product obtained by heating 1 mole of glycine with a mole of chlorine in presence of red phosphorus generates chiral carbon atom. 1 mole of glycine. Structure of glycine you should know. So H2N, this is common. CH, COOH, and here for glycine we have H. Okay? So this is glycine. Now its reaction with phosphorus, red phosphorus and chlorine. This is the same reagent which we use in Hell-Vollard-Zielinski reaction. And in Hell-Vollard-Zielinski reaction, we have to do alpha halogenation. है ना? We get alpha halogenation, halogenated carboxylic acid. ठीक है बेटा? We have to do alpha halogenation. So here we have alpha hydrogen. So 1 mole of chlorine is there. So what do we get over here? We get H2N. In place of one hydrogen, let's put Cl, then COH, and then this. So yes, the product is chiral. Why? Because this carbon is bonded to 4 different groups. So as this carbon is bonded to 4 different groups, so it means chiral carbon. So this is true. Now second, a molecule with 2 carbon atom is always optically active. Question says ki if we have a molecule, suppose COH, we have discussed this, right? COH, here H, OH and H, OH. So question says or statement says a molecule with 2 chiral carbon is always optically active. Is it true? No, it is not true. Why? See, here we have chiral center. This is the chiral center and this is chiral center. Why? If we take this carbon, so one is COH group, one is OH group, one is hydrogen and one is this group, right? Now if I am going to take this carbon, so one COH, one OH, one H and one is this group. Okay? So we have 2 chiral center, but this is optically inactive. This is optically inactive. So why optically inactive? Because we have plane of symmetry. Right, this is, we have plane of symmetry, cuts molecule into 2 equal halves, right? 2 equal halves. So that's why this is optically inactive, or we can say this is achiral. So this is not always true. So this statement is not always true. Okay, not always true. So what do we write? Assertion is true and reason is false. Okay, this is going to be the answer. Now let's do next question. L isomer of tetrose. What is the meaning of tetrose? Tetrose means 4 carbon. So tetrose ka if I want to form the structure, so CHO, then CH2OH. L form means OH is on left hand side, then H. Now we have two possibilities. We have two possibilities. Either OH is going to be on right hand side, or what is the possibility? We can have CH2OH. If OH is over here, तो OH can be over here. ठीक है? So this is erythrose, and this is threose form. That are two forms of the tetrose. We have to find. So question says gives positive Schiff's test. Positive Schiff's test means free aldehyde group should be present. Okay, free CHO group should be present. CHO group is present. As per this, we cannot have option 1 and option 3 as the answer. Why? Because here CHO group is not free. Then has two chiral carbons. So two chiral carbons hai. So on yields triacetate acetylation. It means on acetylation it yields triacetate. So acetylation means ki if we have ROH, so if you react this with CH3COCl in presence of pyridine, or we can say acetic anhydride CH3. So what do we get? Oxygen attacks over here and Cl leaves, right? And we get ROC double bond O CH3 plus HCl. Similarly, we have RO C double bond CH3 plus CH3 C double bond O OH. Okay, we get this. So this part is acetylation and we get ROAC. We can also write like this ROAC. Okay. So triacetate, we get triacetate. It means 3 OH group should be present. Free OH. So 1, 2, 3. They are present. 1, 2, 3 present. In both we have. Next, X is that compound. We have to identify X. On NaBH4, it gives chiral compound. So see, if I am going to react this with NaBH4, it's a reducing agent. So CHO group is converted to CH2OH, then HOH, OHH, and here we write CH2OH. So this is chiral. Why this is chiral? Because no plane of symmetry. Na? We do not have plane of symmetry. If we have the erythrose form, if I have this form CHO, OH or OH, OH, H, H and CH2OH. So in the presence of NaBH4, we get meso compound. CHO group is reduced to CH2OH and we get OH, H, OH, H, CH2OH. Now here we have plane of symmetry, right? Here we have plane of symmetry. So this is a chiral. Understood? So it means what is going to be the correct answer? Option 2 is the correct answer. Is it clear? And if I react this with HNO3, then what happens? CHO is converted to COH, even CH2OH is converted to COH, HOH and OHH. ठीक है जी, clear? So option 2 is going to be the correct answer. Now moving on to the next question, the one that does not stabilize 2 degree and 3 degree structure of proteins. So in 2 degree and 3 degree structure of protein, we have foldings like this. And intensity of folding is higher when we have, or we can say, in 1 degree we do not have such folding. 2 degree mein we have less folding. 3 degree mein we have more extensive folding in that way. So folding increases if you move from 1 degree to quaternary. Okay. Now in the folding we have some kind of linkage which stabilize the folding, and that linkage can be sulfide linkage, van der Waals forces and hydrogen bonding. We do not have this linkage, peroxide linkage, because we have some amino acid in which sulfur is present. So if we have sulfur, then sulfur bonds, sulfur atoms, they are stabilized by sulfur linkage. van der Waals forces, because we have the hydrocarbon part, the carbon hydrogen part is, so they are stabilized by van der Waals forces, and we do have hydrogen bonding in between NH2 and carboxylic acid. Understood? So we do have hydrogen bonding. So which is not there? Oxygen, oxygen linkage, peroxide linkage. It is not there. Now, next question. Okay. Match list 1 with list 2. One letter code. You have to learn this. Okay. So glutamic acid, it is actually E. Glutamine is Q. Okay. Tryptophan is W and tyrosine is Y. Tyro Y. In that way you can learn. It's just I have given you the table. You have to learn it and just solve the question on the basis of that. So A can be matched with third. So we have two options only. A and D. Now B can be matched with first. So it means option D is the correct answer. Okay, option D is the correct answer. Now, next question. Sulfur containing amino acids from the following are, structure पता होना चाहिए, that is cysteine and methionine. Thio means sulfur is present. Okay, so cysteine and methionine में we have sulfur. So this is going to be the correct one. That is B and D. Learn the structures of amino acid. You can solve questions in no time. Next question. Again on one letter code. So we have arginine, right? We have arginine, aspartic acid, asparagine, alanine. So basically alanine is A. Alanine is A. Asparagine is N. Okay, bete. Aspartic acid is D. Ab now rest is R. So A can be matched with fourth. B can be matched with first. So option A. No, we have to. C can be matched with second. So on the basis of that, option C is the correct answer. Just learn one letter code, you can do the question. Next question. Okay, this is based on the enzymes. So sucrose when converted to glucose and fructose, which enzyme is required? That is invertase. Okay, invertase. Sucrose is invert sugar, so in that way you can memorize that is going to be invertase. So A can be matched with third. So we have two options with respect to that, A and B. Now glucose to ethyl alcohol and CO2, so that is zymase. So B can be matched with first. Okay. Now starch to maltose. So maltase, so we can say diastase. Okay. Starch to maltose, we have diastase. So C can be matched with fourth. So option second is going to be the correct answer. And proteins to amino acid, pepsin. Protein digesting enzyme is the pepsin. So D can be matched with option number 2. Clear? Now, next, all structure given below are of vitamin C. Most stable of them is. So see, all structures are. So it means the one which has more resonating structure or hydrogen bonding, that is going to be more stable. So you have to analyze hydrogen bonding and more resonating. So देखो, we can have hydrogen bonding 1. Here we can have one hydrogen bonding. Here we can have one hydrogen bonding, and here also we can have one hydrogen bonding. So hydrogen bonding is going to be same. Now we have to look for the resonating structure. So if you see the resonating structure, so more resonating structure you can form in this one. So that's why B is going to be the more stable form. So see, oxygen 1, ठीक है. Then we have oxygen ka, it comes over here, then this bond shifts over here, right? Clear? Then again we can form resonance from this oxygen, right? So it's just try to form the resonating structures, form resonating structures and find out the correct answer. Okay, bete, that's it. Now let's see next question. Question says alpha halocarboxylic acid on reaction with dilute NH3 gives good yield of alpha amino carboxylic acid, whereas the yield of amine is very low when prepared from alkyl halides. So alpha halocarboxylic acid. Alpha halocarboxylic acid is this. On reaction with ammonia, right? On reaction with ammonia. So what we are going to do? Remove HCl, Cl and H. Okay. So we get CH3, CH, NH2, and then we have COOH. ठीक है, COOH. ठीक है. So alpha halocarboxylic acid on reaction with ammonia gives good yield of alpha amino carboxylic acid. So in alpha position we have amino group, whereas the yield of amine is very low when prepared from alkyl halides. So X on reaction with ammonia, we have to do substitution reaction. So here we get RNH2 and plus HX. ठीक है. अब now here भी तो you are doing nucleophilic substitution reaction, but here if you see we have electron withdrawing group, so that's why attack is easier. Okay, attack is easier, that's why we can have this in good yield. So this statement is true. Now amino acid exists in zwitter ion form in aqueous medium. This is also true, because what happens in aqueous medium, if you have amino acids, so when we have this amino acid, so this is going to exist in form of zwitter ion, that is NH3 positive and CO minus, right? So now we, matlab there is no other, matlab there is no way ki that reaction can be reversed and all. So again we have the formation of neutral amino acid, which can be converted into the zwitter ionic form in that. So this is true. So we can say both A and R are correct, and R is the correct explanation of assertion A. Now let's do the next question. Question says the correct representation in six-membered pyranose form of the following sugar is. Okay, so C, we have C double bond OH. Then we have OH, H, OH, H, H, OH, H, OH, and this is CH2OH. Now, in order to form ring, this oxygen lone pair attacks on this carbonyl carbon. Electron of this bond shifts to oxygen, which can further take this H, not this H, which can further take this H, right? So, what do we have? We are going to write this form. C, OH, H, then OH, H, OH, H, H, OH, H, OH, not OH, this oxygen, and then we have CH2OH. Okay, now here OH is on left hand side, this OH can be on right hand side also, so we can write COHH, oxygen, OHH, OHH, HOH, now this H and this O, and then CH2OH. Okay, now let's do the numbering. So 1 number, 2 number, 3 number, 4 number, 5 number, and 6 number. 1 number, 2 number, 3 number, 4 number, 5 number, and 6 number. Okay. Now when we form the pyranose ring, so pyranose ring is this. So this is 1 number carbon, this is 2, this is 3, this is 4, this is 5, and here we write 6. Like this, na? We have this. Okay. Now right hand side group we are going to write below the plane and left hand side above. So let's see this one. So here OH is right hand side, so here, then H right hand side here, then H right hand side here, OH right hand side here, and this CH2OH is going to be above always. Okay, so we can write the structure as this. So can we compare this structure somehow with any other structure? Yes, we can compare. This is the same structure of D1. Okay, this is the same structure of D1. Why we are not comparing with this structure? Why we are not comparing? Because here on first number carbon, OH is on above the plane. In the options, we do not have OH above the plane. So that's why we have to compare with this structure. If OH is on right hand side, if on carbon number 1 OH is on right hand side, so that is alpha form, and if OH is on left hand side, then that is going to be the beta form. Clear? Beta form. Now let's do next question. So that is based on the test. So first Molish test, that is for carbohydrate. So second biuret test, that is for peptide. So first C carbylamine test, that is for primary amine. Third, and Schiff's test, that is for aldehyde. So just match this. So A option can be matched with second, then B first, C third, and D fourth. Okay, so this is based on, this is the concept of POC at all. So you should know which test is for which functional group, right? That's it. Now next, a protein X with molecular weight of 70,000 on hydrolysis gives amino acid. One of these amino acids is. Up now we know that amino acids should be alpha L amino acids, right? Alpha L amino acids. If you see over here, this is alpha, this is beta, this is gamma, this is delta. This is delta amino acid. This is alpha, beta, gamma. This is gamma amino acid. This is alpha amino acid, and this is alpha and beta, this is beta amino acid. So this is alpha amino acid. So amino acid structure can be this. Option C should be the correct answer. Okay. Now, next question. Following tetrapeptides can be represented as. Following tetrapeptides can be represented as. Again, you need to know the structure of amino acid, and with respect to that, you should know the letter code. Okay. So see, this is COH group and this is NH. This is again COH group and this is NH. This is again COH group. This is NH. Okay. So we have this kind of structure, right? This kind of structure. Up now the point is that here we should be having oxygen. Okay. It means when two amino acids combine, you say here we have COH and here we have H2N. So we are going to remove water, na bache? We are going to remove water. So we have C double bond O NH linkage. We have this linkage. It means here two amino acids combine. Here also two amino acids combine, and here also two amino acids combine. It means what do we need to check now? We need to check the alkyl group. Alkyl group. So this is the alkyl group now. This. CH2 and then phenyl ring and this OH. So this is for tyrosine. So tyrosine, and tyrosine letter code is Y. Tyrosine letter code is Y. Then we have this group CH2COH. So this is for aspartic acid. Aspartic acid, and the letter code is D. Okay. Then we have CH2CH3. So this is for leucine. Leucine. So letter code is L. Okay. L. So as per this, we can have either C or D. Now check this one, CH2 phenyl. So this is phenylalanine. Phenylalanine. So here this is F. So option D is the correct answer. That is FLDY. Okay. So structures are important. Letter codes, they are important. Now let's do next question. Number of cyclic tripeptides formed with two amino acids A and B. Two amino acids A and B. So see, we have two amino acids A and B, and we have to form tripeptides. Tripeptide, right? So tripeptide from two amino acids. So it means we can have different possibilities now. We can have AAA, we can have AAB, we can have ABA, right? We can have ABA and we can have ABB. Okay, next we can have BBB, we can have BA, or we can say BBA, then we can have BAB, and then we can have BAA. So these are the possibilities. But now we have situation, we have cyclic tripeptides. So see, we can have AAA. Okay, bache. We can have BBB. Now we can have ABA because tripeptide cyclic hai, so we have to join like this, and we can have BAB. Now see, if we say ABA, so ABA is this. We can also see it like this, AAB. So it means AAB, right? We can see it like this. We can also see it like this, BAA. Understood? BAA. So three amino acids are in the same one. ठीक है, मतलब this series is going to be in one. Now see BAB. So BAB is this, then BBA. BBA is this, and then ABB. That is this. Okay. So that's why how many cyclic tripeptides can be formed? That is 4. Okay. AAA, BBB, ABA, and BEB. ठीक है. Option 4th is going to be the answer. Otherwise, if we do not have cyclic peptide, then we can have total 8. Now next question. Match items of row 1 with those of row 2. Okay, fine. In row 2 we have fructofuranose, alpha form, beta form and all. ठीक है बेटे. So first of all, if OH is on right hand side, then that is alpha form, and if OH is on left hand side, so that is going to be the beta form. ठीक है, that is going to be in beta form, and whatever is present on right hand side we have to put it down, and whatever is present on left hand side, so we have to put it above. So see this OH, right? So how do we say that? So देखो, we have glucose वाला thing and we can have the fructose वाला thing. So glucose में we take help from the pyrene ring. ठीक है. अब see here, OH is on right hand side. OH is on right hand side now. So this is alpha D glucopyranose. Okay. Now here OH is on left hand side. That's why it is above. Right? That's why it is above. So that is on carbon number 1. I am talking about carbon number 1. So this is beta. Beta D glucopyranose. Clear? So it means A can be matched. A can be matched with third, and B can be matched with fourth. Now similarly we have to check for fructose. So in the fructose we have two possibilities, CH2OH and OH, right bitches? So OH is on right hand side now. So if OH is on right hand side, so this is alpha D fructofuranose. Fructofuranose. And this is on left hand side, that's why it is above. So this is beta D fructofuranose. So C can be matched with first and D can be matched with second. So on the basis of that, option A is the correct answer. Okay, now next question. Amylose is insoluble in water. So देखो, we have starch. Starch में we have two parts, amylose and amylopectin. Okay, amylose is water soluble while amylopectin is water insoluble. Okay, amylose में we have linear structure and amylopectin में we have branch structure. So amylose is insoluble in water, so this is false. Why it is soluble? Amylose is a long linear molecule with more than, that is true. Okay, so it means assertion is false but reason is correct. Assertion is false and reason is correct. Okay, now let's do next question. So here we have fructose. Fructose on reaction with HCN. So see fructose. So this is C double bond O, and here we write CH2OH, then CH2OH, 3, 4, 5, 6. So OH, OH and OH, H, H, H. So this is fructose. Now what happens on reaction with HCN then H2O positive? HCN and H2O positive. So Cn minus attacks on this carbonyl carbon, electron of this bond shifts over here, which will further take H plus. Right, and on hydrolysis Cn is converted to carboxylic acid. So I'm writing this directly. So what do we get? We get CH2OH, and here we get अच्छा, only hydrolysis है ना, तो ठीक है. So COH, and here we write COOH, then we have CHOH whole thrice, and then CH2OH. Okay बच्चे, so we get this. So this is A. Now let's look for NaBH4. NaBH4 reduction. So ketone is reduced to alcohol. Then we have CHOH whole thrice and CH2OH. And in the presence of red phosphorus, sorry, Hi and phosphorus in presence of Hi. So we get N-hexane. Okay, and what is the formula for hexane? C6H40. Now we can either have option A or option C. So now you have to find out the total number of carbon atoms and hydrogen atoms. Then you can find out the correct answer. Option A is the correct answer given over here. Okay, it's just you need to find out the total number of hydrogen atoms. So there is a difference of hydrogen atoms. So count. So 2, 3. Then we have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So okay, A is going to be the correct answer. Okay, now next question. Okay, so this is based on the catalyst. Okay, catalyst. So for this sucrose C12H22 sucrose, we need H2SO4. So C can be matched with second. Haber's process, B is Haber's process. So Haber's process can be matched with iron. B can be matched with fourth. So just check, can we match this thing? So C can be matched with fourth and B can be matched with second. So on the basis of that, we can find out the correct answer. Option C is the correct answer. Okay, that's it. There is no need to know other catalyst, but yes, you can compare otherwise. Next question. For the below given cyclic hemiacetal X, the correct pyranose structure is correct pyranose. So what we are going to do? So just let's form pyranose ring. This is carbon 1, 2, 3, 4, 5, 6. So here hydrogen is on right hand side na. So here we put H. Here also H. Here OH. Here H. And here CH2H OH above. Okay. So this is going to be the correct structure. Now you have to match. Let's match with the correct structure. So this is H na. No. I'm sorry, 1 minute. H. OH. Okay, here we put H. Okay. So we can match this with option number D. Right? We can match this with option number D. So this is the only way. Right hand side below, left hand side above. Now next question. Find, these are based on the chemical reactions of glucose. So glucose in presence of Hi, it gives hexane. So A can be matched with fourth. Then glucose plus Br2 water. So we get gluconic acid. So B can be matched with first. Then glucose plus acetic anhydride. We get pentaacetate. So C can be matched with second. Glucose plus HNO3. We get saccharic acid. Third. Okay. So on the basis of that, A is fourth, B first, C second and D third. Okay. Let me tell you all the reactions. So see, we have glucose now. So glucose is basically CHO, then 2, 3, 4. Here CH2OH, OH and OH. H. So in the presence of HI, what happens? Every functional group is going to reduce and we have hexane and hexane. Okay, and hexane. Then we have what? Br2 water. So Br2 water, in the presence of Br2 water, it's a mild oxidizing agent. So in mild oxidizing agent, CHO is converted to carboxylic acid. So we get CHOH 1, 2, 3, 4. 4 times and then CH2OH. Then we have HNO3, I guess. So HNO3 में even CH2OH is converted to carboxylic acid. So CHOH whole 4 and here COH. Last, we have acetic anhydride. Acetic anhydride means CH3 C double bond O, C double bond O, CH3. So already discussed this reaction. So in place of OH, we put OAC. So here we have CHO and here we have 1, 2, 3, 4, 5. So CH, OAC, 4 times and then CH2OAC. Understood? So in that way we can get glucose pentacetate. Clear? Okay, fine. Now let's do next question. As sugar X dehydrates very slowly under acidic condition to give furfural, which on further reaction with resorcinol gives the colored product after some time, sugar X's. So this is called Selin Vanoff test. Vanoff test. So what happens? There is a sugar which on dehydrates gives furfural. Furfural is this. Okay. Now which on reaction with resorcinol? Resorcinol is this. Gives colored product. So we get the colored product like this. OH. This is O. Then find double bond O. This is, and here we write something like that. This is 1, 2, and this. Okay, so this is Sullivanov test and we get red color of this. So that happens in the presence of aldopentose. Pentose होना चाहिए ना, because then only we get मतलब ये फर्फ्यूरल होगा. ठीक है? That's it. Aldopentose, it can give this test. Okay, animal starch is the other name of mammary based glycogen. Mammary based. Now next question. Which one of the following is the reducing sugar? So for the reducing sugar, we should find the hemiacetal group. It means OH and this OR. So see, this oxygen is bonded to carbon, fine, and this carbon is bonded to OH. This oxygen is bonded to carbon and this oxygen is bonded to carbon which is connected to OH. So here we have hemiacetal group. So this is going to be the answer. Check over here. This oxygen is connected to carbon, this oxygen is also connected to carbon, but adjacent carbon is not bonded to OH. So no hemiacetal group. Okay, no hemiacetal group. So non-reducing. Here check, this oxygen is connected to carbon, but adjacent carbon is not bonded to OH. This oxygen is connected to carbon, this oxygen is bonded to carbon, but none of them is bonded to OH. So no hemiacetal. Here we do not have free CHO group. Here no free CHO group. So that's a non-reducing. So option A is the correct answer. Now glycosidic linkage in between 1 of alpha and C2 of beta fructose. This is also based on memory. So C1 and C2 glycosidic linkage is present in sucrose. Okay, sucrose is made from alpha glucose and beta fructose. So answer is sucrose. Now next, during the denaturation protein, which of these structure will remain intact? Primary, mammary based. Because in secondary, tertiary and quaternary we have the foldings, and on heating or on denaturation, what happens? Folding gets unfold. And then at last we have only the primary structure of the protein. Next, a sugar produced after complete hydrolysis of DNA. So in DNA, which sugar is present? Already I have provided you. So that is a pentose sugar. So in DNA, we have 2-deoxyribose sugar. Okay. So pentose sugar is there in DNA. Next, structure of protein that is unaffected by heating. It means denaturation, no effect. That is the primary structure of the protein, mammary based. Next, sugar moiety in DNA and RNA molecules respectively. So in DNA में which sugar is present? Beta D2-deoxyribose and RNA में beta D ribose. So in DNA we have D2-deoxyribose and in RNA we have ribose sugar. Next, when sugar X is boiled with dilute H2SO4 in alcoholic solution, two isomers A and B are formed. A on oxidation with HNO3 yields saccharic acid, whereas B is levorotatory. Their compound is sucrose. Why it is sucrose? See, sucrose gives alpha D glucose and beta D fructose. And fructose is levorotatory, na? Levorotatory. It rotates the PPL to left hand side. Okay, and alpha D glucose, which is the dextrorotatory. And we know that glucose on reaction with HNO3 forms saccharic acid. CHO is converted to COH over here. Even CH2OH is converted to COOH. Okay. Now let's do the next question. Stability of alpha helix structure of proteins depends on, obviously, alpha helix structure. It's like this structure. Okay, like this. So the stability, because we have foldings now, so stability of alpha helix structure of proteins depends on hydrogen bonding interaction. Okay, so that is hydrogen bonding. Completely memory based question. Now let's do next question. Question says maltose has two alpha D glucose units linked at C1 and C4 glycosidic linkage and is reducing, which is very true. It is true. Maltose is formed from alpha D glucose and we have glycosidic linkage in between carbon number 1 of one alpha D glucose and carbon number 4 of another alpha D glucose. Except for sucrose, in every other carbohydrate, we have 1 and 4 glycosidic linkage. In sucrose, we have 1 and 2 glycosidic linkage. So here maltose has two monosaccharides, alpha D glucose and beta D glucose linked at C1 and C6 and it's not, no, this is false. So statement 1 is true, but statement 2 is false. Now, next question. L isomer of a compound A, C4H8O4, gives positive test with this. This is what? Silver ammonical nitrate solution, tolerance. So it means free aldehyde group is present. Free CHO group is present. That's the important part. L isomer, it means if we have CH2OH, then this OH is present on left hand side. So that's L isomer. Treatment of A with acetic anhydride yields triacetate derivative. Triacetate derivative means 3 OH group should be present. Fine. Compound A produces an optically active compound B and an optically inactive compound C on treatment with bromine, water and HNO3 respectively. Now you have to check. Suppose I am going to take this CHO. So if this on treatment with Br2 water, so Br2 water converts CH2OH to, not CH2OH to CHO2 COOH. Okay, OH, H, OH, H and CH2OH. And in with treatment of HNO3, with HNO3, we get COOH, COOH, OH, H, OH, H. So question says compound A produces an optically active compound B. So this is B and this is going to be C, which is optically inactive. Why optically inactive? Because we have plane of symmetry over here. Plane of symmetry is present. Do we have 3 OH group? Yes, we have 3 OH group. 1, 2, 3. Right? 1, 2, 3 OH group. So it means option A is the correct answer. So in that way you have to check. Now moving on to the next question. Again that is based on the enzyme. So what is the role of invertase? Invertase role is to convert glucose into ethanol. So A can be matched with option number 3. Right? Just give me a moment. A can be matched with option number 3. Not invertase, I'm sorry. Invertase is cane sugar into glucose, na? Invert sugar, right? So A can be matched with option number 4. Then B, zymase. Zymase can be matched with glucose into ethanol. So B can be matched with option number 3. Okay, B can be matched with option number 3. So on the basis of that, what do we have? A, 4th and B, 3. So option C is the correct answer. Understood? Option C is the correct answer. That's it. Now, which one of the following is a water soluble? It's completely memory based. Memory based. You have to learn the vitamins chart. So that is answer vitamin B12. Next, which of the following is not an example of fibrous protein? So one of the most important part of fibrous protein, they are water insoluble. Water insoluble. So keratin, they are present in here, water insoluble. Okay, collagen, myosin muscle fibers, so they are all water insoluble. So what is going to be the answer, which is not an example of fibrous protein? That is going to be albumin, which is present in egg. Next, which of one of the following compounds contain beta C1 C4 glycosidic linkage? So you have to find out in which beta is present. Okay, beta form is present in which one? So sucrose may we have alpha beta, Maltose में we have alpha. Amylose is a part of starch, right? Amylose is a part of starch, so we have lactose. एक मिनट, in the above one we have discussed ना, starch, it's starch. Just let me correct this. This is starch ना, so this is formed from alpha glucose. ठीक है, alpha glucose. That is sucrose, in which alpha glucose and beta fructose is present, right? Alpha glucose and beta fructose is present. That is the sucrose. Fine. So lactose. Then we have. So answer is lactose basically. ठीक है. Sucrose में alpha glucose plus beta fructose. Maltose में alpha glucose. And amylose is a part of starch, so which is also formed from alpha glucose. Okay. Now next, hydrolysis of sucrose gives, already discussed, alpha D glucose, and glucose is dextrorotatory. That's why we have positive sign, and fructose is levorotatory. That's why we have negative signs. So option D is the correct answer. Okay. Moving on to the next question. Completely memory based. Which one of the following isomer forms of uracil, which one is present in RNA? So you should know the structure of uracil. So option D is the correct answer. See, this is the structure of uracil. So just learn the structure, you can take the correct answer. Now I'm doing the last question for this biomolecules. Rest questions are basically same. Just learn and then do the questions. I will mark the correct answers, okay, in this slide. So question is ki sucrose is a disaccharide and a non-reducing sugar. It is true. Sucrose is a disaccharide and a non-reducing sugar. Yeah, it is true. Disaccharide hai, but it is non-reducing. Why? Because hemiacetal linkage is not present. Hemiacetal linkage is not present. Now, sucrose involves glycosidic linkage between C1 of beta glucose and C2 of alpha fructose. C1 of beta glucose and C2 of alpha fructose. C1 of beta glucose and C2 of alpha glucose. No, that is not true. Because here we have alpha glucose and beta fructose. Okay, so assertion is true and reason is false. Clear? ठीक है, all questions are same, other questions are same. So I have discussed enough questions of biomolecules. Just read, learn and solve on your own. Okay, so bye, take care.